Hi everyone. In this video, we are going to discuss about dynamic programming, that is DP. I believe you might have heard from someone that that particular problem was based on DP, or this solution is totally based on DP. So what is this DP and why we need to learn this DP concept? So everything about DP in this video we are going to discuss. So without further ado, let's get into this. So here I'm going to write first DP, that means dynamic programming. And honestly speaking, guys, the definition of DP is just one line, and definition says we use DP whenever we need to optimize our solution. So the keyword you need to remember is optimize. So for optimization, we use a DP. And as I have already told you in the beginning that we are going to discuss DP in detail. So let's discuss in detail. So when we should use a DP in our problem? We can use the DP technique when we can say that our problem can be divided into subparts. So whenever our problem is can be divided into subproblem, we can use dynamic programming. Or we can say that whenever our problem is based on overlapping, means our subproblems are overlapping to each other, then we can say that we can use a DP. Alright. Now we are going to discuss the DP with an example of Fibonacci series. And Fibonacci is a very famous problem. I believe that you must have learned it. But if you haven't learned, then let me tell you the definition of Fibonacci series. So let me write here Fibonacci series. Okay. So what does this series says? We have fixed first two number 0 and 1. Fine. Now rest of the number we have to calculate by using a last two number. So the next number, that is a third number, is totally based on the last two number, the addition of last two number. So 0 plus 1 is going to be 1. So next number is 1. Again the next number is totally based on the last two number, that is 1 plus 1 is 2. So this one number is also based on last two number, 2 plus 1 3, and similarly 5 and 8, so on up to infinite. So this is a Fibonacci series. So in this video, we are going to see how we can use a DP in Fibonacci series. And also we are going to see about top down and bottom up approach by using this Fibonacci series. So now guys, assume that a person come to you and say, tell me the sum of first 5 Fibonacci series. Alright. So what you will do? You can use here a recursion because you are not familiar with DP right now. I'm assuming that. So what you can do? You can use a recursion as well. And also, in if you know C++, Java, or Python programming language or any other programming language, then you must have learned this recursion as well. And in the recursion, you must have learned this Fibonacci series. If you haven't, don't worry, we are going to discuss right now. So how we can calculate the sum of first 5 term of Fibonacci series? We can use the recursion. So in recursion, we are going to use a code like this. So we are going to use a function. We can say function name is fun. And in this function, we are going to take a number n. And after that, we can say that if our n is 0 or n is equal to 1, then you can return that particular n, right? Because we have seen in an example that Fibonacci series always start from 0 or 1. So if 0 term or 1 term we come to know that 0 index or 1 index, then we can return that particular index, because in the 0 index we have a value 0, in 1 index also we have a value 1. So that is clear, right? Now guys, one more thing, if it is not the case we have any bigger term, then we can use again this function. We can say return fun n minus 1 plus fun n minus 2. So we can see that that particular number is going to be the addition of last term and last minus 2 term. So if the number is 3, then we can see that 3 is totally based on 2, the last term, and the last minus 1, that means 1. The number 3 is totally based on second and first index. So that is very clear, right? So now guys, how we can visualize this code with a recursion? So let's quickly see this. I want to calculate the sum of first 5 term of Fibonacci series. So I'm going to call this function fun5. Okay. And next time I'm not going to use this 5. I'm going to use this number only. So this number is greater than 1, right? It is not equal to 0 or 1. So it is greater than 1. So we can say that 5 is going to call 4 as well as 3, right? Now that is clear. Now guys, this 4 is also not equal to 0 or 1. It is also going to call 3 and 2, the last term and last minus 1 also term. In 3 also we are going to call 2 and 1. And here 3 also are bigger than 1, then this is also going to call 2 and 1. And 2 is also going to call 1 and 0 because it is also not equal to 0 or 1. And this 2 also going to call 1 or 0. And guys, this one is our base condition because we have used this condition here above. Let me show you. Here you can see that we have used this one, n is equal to 0 or 1, so return 1. So here we can see that we got 1, that means it is going to return value 1. Okay, so it is not going to expand here. And here 2 is also not equal to 0 or 1, so it is also going to expand 1 and 0. Now guys, you can see that we reached to all the base condition. So here also it going to return 1, here it will return 0, here it will return 0. Let me use a different pen. So I'm going to remove this one. I'm going to use a different color. Alright, so this is also going to return a value 1, right? So we can say this one is going to return 1, this is going to return 0, this is going to return 1, this is 1, this is 0, this is 1, this is 0, this is 1. Fine. Now guys, How does recursion work? We already know this, but here we are going to discuss it. So this 1 and 0 is going to add and it is going to return the value to 2. So 2 will have a value 1, and we are very familiar that, let me write here some Fibonacci series. So it is start from 0, 1, 1, 2, 3, and 5 and 8, so on up to this. This is a Fibonacci series. So at 0 index, let me write here index as well. So this is 0 index, this is first index, this is second index, this is third index, fourth index, fifth index, sixth index. So at second index, we are getting a value 1, right? And here also you can see that at second index, we got a value 1. Fine. Now guys, this one, for getting a value of 3, this is going to call this 2 and 1. So we have a value of 2. So we can say the value of 2 is 1. So 1 plus 1 is going to value of 2. So at third index also you can check it, we have a value 2. Now guys, at fourth index, we have to call this 2. So here you guys, you can see that if we are start again calling this 2, then it will go in the depth again, right? So guys, what we can do, we can use a memoization. So we can use here a DP technique, because here we don't want it to call it again. We have already stored the data, right? We have already calculated first time this 2. Why we need to calculate it again? So we can use here memoization. We can use a DP and we can store the data. We can tell her that at second index, we have already calculated some value. We don't want to expand it again. So we can see that at second index, we have a value that is 1. Here we have already calculated that is 1. So we are going to say at second index, don't go in depth again. Just return 1 here only. So it will not go in depth. It will return 1, and 2 plus 1, 3. At fourth index, we will get a value 3. And similarly, then we will move to this 3, particular 3. And we can say that don't expand here, because we have already calculated this 3 as well. You can see that this whole is nothing but 3. Let me use a different color to make a clear. So this 3 is nothing but we have already calculated this sub part. So we can say that this 3 is going to store a value 2. I know this might become a confusing, but just try to understand it and you will get a better idea at the end. I make sure you that. So 3 plus 2 is nothing but 5. So at 5, we are having a value 5. And here also you can cross verify that the value at 5 index is 5. So we don't need to calculate all these things again, this one again, because we have already calculated it once. So this is a part of sub problem. We are dividing our solution in sub problem at 4th and 3, and we are just expanding it only one time. And in the second time, we are just using the first calculated value. So this is called a top-down approach. Remember guys, this is nothing but a top-down approach where we use a memoization and recursion. I hope you understood it. What is top-down approach? We use a recursion, then we memoize it, and we use simply in our solution. So this is a one type of DP problem, and I believe that you must understood it. If you haven't understood, you can write in the comment section. I'll try to help you. Now guys, there is another approach, that is bottom-up approach. Now let's discuss about that approach. So guys, we are going to learn about bottom-up approach. Let me write a bottom-up. This is, we are going to learn with the same example. So bottom-up approach. So guys, what does this approach say? This approach use a tabulation instead of recursion. Means it use a matrix. And if we take a same example, if we want to find the sum of first 5 term of Fibonacci series, then we have to create a tabulation, a matrix. So let me create a matrix. So I am going to say I want to find a Fibonacci series, means sum of 5 term of Fibonacci series. So I'm going to create a tabulation where I'm going to create a matrix, or we can say array of 6 size. And why we create a 6 size, we are going to discuss in detail in the next videos. But for now, I'm going to create a 6 size. So here it is going to 0, 1, 2, 3, 4, 5, and this 6. Now guys, it become a 7 size if we calculate 1, 2, 3, 4, 5, 6, 7. So let me remove this one side. Alright, so this is a 6 size array. Now guys, what we know? We know what base condition, that is, we know first two value of Fibonacci series, that is 0 and 1. So we are going to say at 0 index the value will be 0, at 1 index the value will be 1. That is for sure, right? So now how we can calculate the value of 2, 3, 4, 5? So because we need to find the value of 5, we need to traverse from second index to 5 index. And we are going to use the pre-calculated value. How we can use it? So let's discuss it by solving this problem. So what I'm going to do guys, I'm going to say here that at second index, we are at second index. So at second index, use the value which is at second minus 1, 2 minus 1 plus at 2 minus 2. So here we are not using a recursion. Here it says saying that the next left address and the next left to left address value, just add these two value and we are going to get our this index value. So here at second index, the next left index is 1 and next left to left index is 0. So the addition of these two values is going to be this value. So here let me write 1, not 2, because 0 plus 1 is 1. Alright guys. Now guys, we are moving to next iteration. At third index, we are going to say the next left address value, that is 1, and next left to left index value, that is 1. So 1 plus 1 is 2. And here again next left index value there is a 2 plus next left to left index value, that is 1. 2 plus 1 is 3. Same, 2 plus 3 is 5. So we calculated the value of 5 index by just using a iteration, by just using a traversing this matrix. So this is why we call it bottom up approach. We reached our solution by using a pre-calculated value. So guys, that's all in this video. In this video, my main motive was to tell you about DP, what is actual DP, and what are bottom up approach, top down approach, and here we can use this DP technique. And guys, in this playlist, we are going to solve a lot of problem that is based on dynamic programming. We are going to solve a problem based on bottom up approach, top down approach. And guys, if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.